Good morning. Today is June 14, 2020. And once again, this is Teacher Ariel. Our subject is measurements and experiments. Our topic for today is basics of oscilloscope. Objectives. At the end of this lesson, the trainee should be able to explain what is an oscilloscope, its function and uses, describe the oscilloscope screen or graticule, its given access and values, calculate given computation, and lastly, measure various electrical electronic waveforms. What is oscilloscope? Or what is an oscilloscope? An oscilloscope is a diagnostic instrument that draws a graph of electrical signal, meaning it displays a graph of electrical signal to tell you about the time, voltage, value, and the frequency of a specific signal. These informations will tell you if an electrical or electronic equipment is functioning well or not, how much of a signal is AC or DC, and how much of a signal is noise, and whether the noise is changing with time. Let us now proceed to understanding oscilloscope screen graticule. So the vertical line at the middle of the screen is the y-axis, or it represents as the amplitude is equal to voltage. So the y-axis represents as the voltage of the screen. The horizontal line represents as the x-axis, or the time, which is expressed in seconds. This is the y-axis in voltage, and the x-axis, which is expressed in seconds. So this is the screen of the oscilloscope, which has a measurement of 8 by 10 centimeter. So meaning the horizontal section of the screen is composed of 10 boxes, and the vertical section of the screen is composed of 8 boxes. So the y-axis, or the voltage, is located at the middle of the graticule, or of the screen, vertically. Then the x-axis is located at the middle horizontally of the screen. So here is the representation of the screen of the oscilloscope. When calculating for the peak voltage, since the screen is divided into two hemispheres, the up or the upper portion and the lower portion, the upper portion after the horizontal line is the positive peak voltage, and the lower portion is the negative peak voltage. So meaning this line, or this axis, is 0. Okay, so this horizontal line is 0, down is negative, and up is positive portion of the screen. And the whole screen can represent as the voltage or peak-to-peak voltage. I will explain it further in our discussion. So say for example, the volts per division is equal to 2 volt or set to 2 volt, and the signal reaches the second box from the 0 position, the second box. So we have peak voltage is equal to 2 volts, which is given by the volts per division multiplied by 2 boxes. So we have 4 volts as peak voltage. Again, if the volts per division is set to 2 volt and the signal reaches at this portion, meaning it covers 2 boxes. So on how you're going to compute, peak voltage is equal to 2 volts times 2, which is 2 boxes, is equal to 4 volts. So our peak voltage is 4 volts, positive 4 volts. Again, if the signal reaches at this point, covering 2 boxes, 1, 2, meaning the 1 box is equal to 2 volts. So there are 2 boxes, then this is 2 plus 2 is equal to 4 volts, or 2 boxes times 2 volts is equal to 4 volts. Clear? Another example. The volts per division is set to 5 volts, and the peak of the signal reaches up to the maximum of 3 boxes from 0, 1, 2, 3. So we have 5 volts as given to the volts per division times 3 boxes is equal to 15 volts. Meaning 1 box is equal to 5 volts plus 5 volts plus 5 volts. Then we have 15 volts. Peak voltage is equal to 5 volts times 3 is equal to 15 volts. This voltage here, or the volts per division, can be set from the knob of the oscilloscope. Again, we set the volts per division to 5 volts, and the signal is up to this point, covering 3 boxes, 1, 2, 3. So you occupied, or the signal occupied 3 boxes. So 5 times 3 is equal to 15 volts. So peak voltage is equal to 15 volts. Meaning each line, or each box is equal to 5 volts. 5 plus 5 plus 5. Another example. Now again we set the volts per division to 2 volts. Then on the lower part, negative part or negative section of the screen, it occupies also 2 boxes, 1, 2. Then peak voltage is equal to 2 volts times 2, or 2 boxes is equal to 4 volts. Meaning 1 box is equivalent to 2 volts, so 2 volts plus 2 volts is equal to 4 volts. But this peak voltage is on the negative side. So you can compute the peak voltage either on the positive side or on the negative side of the screen. Another example, 5 volts as set in the volts per division knob. Then the signal occupy up to this level, which indicates 1, 2, 3 boxes. 5 volts times 3 boxes is equivalent to 15 volts or negative 15 volts. So B peak or peak voltage is equal to negative 15 volts. This is very simple on how to compute for the peak voltage of the oscilloscope. Now let's have some exercise. The volts per division is set to 1 volt. Then the signal reaches on this level only, occupying 1 box. What is the peak voltage? So to transpose 1 volt, or peak voltage is equal to 1 volt times 1 box is equal to 1 volt. Meaning this box is equal to 1 volt. Okay? Again, volts per division is 1 volt, and the signal occupy 1 box only, meaning each box is equal to 1 volt. So, how to compute? Peak voltage is equal to 1 volt times 1 box is equal to 1 volt. Clear? Next exercise. The volts per division is set to 20 volts. And on the lower side or lower part of the screen, the signal occupies 2 boxes from 0 going to this peak. 1 box, another 1 box. So meaning the signal occupy 2 boxes. 20 or peak voltage is equal to 20 volts times 2 is equal to negative 40 volts. Again, 20 times 2 is equal to negative 40 volts. Meaning, this box is 20 plus another 20, we have 40 volts. Negative 40 volts. Because, as I have said, the upper portion of the screen is positive and the lower portion of the screen is negative. Another example on how to compute for the peak-to-peak voltage, meaning we're going to compute for the two parts of the screen, the upper portion and the negative portion. Let us say the volts per division is set to 2 volts, and on the upper part it occupies 1, 2, 3, and the lower part it occupies 1, 2, 3. So all in all, from 0, 3 up, and 3 down, we have 6 boxes. 1, 2, 3, 4, 5, 6. So 2 volts times 6 is equal to 12 volts peak to peak. So peak to peak voltage is from this portion to this portion. The whole part of the signal. 3 up and 3 down. We are computing for the whole section of the screen. So in this case, we have 1, 2, 3, 1, 2, 3. We have 6 boxes. Then each box is composed of or consisting of 2 volts. The value is 2 volts. So 2, 4, 6, 8, 10, 12. So we have 12 volts. So 6 times 2 is equal to 12 volts peak to peak. Not peak voltage but peak to peak, meaning peak, positive peak and negative peak. Okay? Another example on how to compute for the peak to peak voltage. The volts per division is set to 5 volts and it occupies only 1 box up and 1 box down, meaning to say we have 2 boxes here. So 1 box is 5 volts, another box is 5 volts. So we have 5 volts times 2. Our peak to peak voltage is 10 volts. Peak voltage here is 5, peak voltage here is 5, peak to peak is 10 volts. Okay? So first, look at the boxes occupied by the signal. Okay, exercise. The volts per division is set to 2 volts. How you're going to compute for the peak-to-peak voltage? In this example or exercise, the upper portion occupied 2 boxes, 1, 2. The lower portion occupied 2 boxes also, 1, 2. So there are 4 boxes. So 2 volts times 4 boxes is equal to 8 volts. Meaning this is 2 plus 2, 4, 2 plus 2, 4, 4 plus 4 is 8. So our peak-to-peak voltage is 8 volts. 2, 4, 6, 8. 8 volts. 2 times 4 is equal to 8 volts peak to peak. I hope you can follow this example. Now, another example, I have put the signal here, the sinusoidal wave or the sine wave, as you can see on the this red signal. This is the sine wave. Then, the volts per division, we are going to compute here the peak voltage and peak to peak. The volts per division is 2. Then, the peak voltage occupy 2 boxes. 1, 2. Meaning, 1 box is equal to 2. Then, there are 2 boxes. So, we have 2 plus 2, 4. Our peak voltage is 4. 2 times 2 is equal to 4 volts. Now, down also 1, 2. So, the peak voltage is also 2 volts. Now, how to compute for the peak-to-peak voltage also? You need to count the number of boxes occupied by this whole signal. We are talking about the amplitude, the vertical portion. So, there are how many boxes? 1, 2, 3, 4. So, this signal here, this signal here. There are 4 boxes, so our peak-to-peak is equal to 2 volts times 4 boxes. So, we have 8 volts peak-to-peak. The peak voltage is equal to 4 volts. Peak-to-peak is 8 volts. Meaning, you just multiply the peak voltage into 2. Because there are 2 parts of this screen. The upper and the lower part of the screen. Since we have 4 volts times 2, so we have 8 volts. Or just count the number of boxes occupied by this signal, sine wave. Here is another example. The volts per division is set to 10 volts and here is the sinusoidal wave or sine wave. The other part of the signal occupies almost 3 boxes. 1, 2, 3. So this signal occupies 3 boxes and the lower part also occupies 3 boxes. This is the peak. 1, 2, 3. This part 1, 2, 3. Now, to compute for the peak voltage, we have 10 volts times 3 boxes is equal to 30 volts. The peak voltage is equal to 30 volts. Then, to compute for the peak-to-peak voltage, since peak-to-peak voltage, we compute for the whole amplitude of this signal. So, we have 3 up and 3 down. 1, 2, 3. This one. Then 1, 2, 3. So we have 6 boxes all in all. So the volts per division is 10 volts times 6 boxes. We have 60 volts as our peak-to-peak voltage. Meaning we are going to look for or take this peak and take this peak. So in this example, we have 60 volts as our peak-to-peak voltage. And our peak voltage is 30 volts since it occupies 3 boxes. 3 times 10 is 30 volts. Now, let us proceed to your assignment. This assignment will be submitted to me next week. And please try to answer this problem given to you. The volts per division is set to 4 volts and the signal, which is a triangular wave, reaches only or occupies only 1 box. Compute for the peak voltage and the peak-to-peak voltage. Another one assignment. The volts per division is set to 20 volts and the triangular wave occupies 2 boxes. This is the peak. It occupies two boxes. So compute for the peak voltage and the peak-to-peak voltage. And submit these two assignments given to you by next week. So next week topic will be a continuation of our discussion of the oscilloscope screen and Graticule. So by next week, we are going to compute for the time and frequency. Because today's topic, we computed for the voltage, which is the vertical part of the screen. And next week, we are going to discuss the horizontal part, which is the time, computation, and frequency. Thank you and keep safe always.